Hello, and welcome to part 5 of the series that I've been calling To Shell and Back Again. This is for the video game Greyhack, and we'll be showcasing the tool called Shell, written by Pluto, written using the in-game programming language called greyscript. In this video, I'm gonna just try some random networks and just kind of showcase how to access a computer that has no open ports. Um, obviously, the kind of easy way is if there's forwarded ports. And again, this is for the game Greyhack. This isn't real life. But if there are forwarded ports, you can connect on one of those ports and run some exploits against vulnerabilities in the service that's running on that port. And doing so, you can gain access that way. But if what you need to access is on a computer that has no services running, has no open ports, nothing that's routed or available internally, then you may have a hard time figuring out how to get access to that computer. And I'm going to show you how to do it. We'll use what's called, really the only way to do it is to use what's called a bounce exploit. And that's just kind of a colloquial term that players have come up with. It's not, we don't see that term in the game anywhere. But basically what that means is it's an exploit on a router. This is only possible on a router where you can actually pass in a third parameter, which is the LAN IP address of a target that you want to gain access to. And the exploit will give you back a computer object representing that target. And you can use the computer object to, look at files in the file system. You can read the mail.txt file and get access to users' email accounts. And then from there, you can send them the funny game social engineering email, which will get you an rshell on the server. So we'll go through that process all the way to rshell. If you're not sure how to use an rshell server, how to do rshell stuff, I have a video earlier in this series. I think it's maybe part 1 or part 2. I think it's part 2, where we go through setting up a rental server for use as an rshell server with shell. So we'll rely on that setup here. So let's go ahead and get started. So I'm not going to do like a mission for this. I'm just going to grab a random IP address. Although, obviously this is the scenario in which you would need to do this would typically be for a mission. But since I, can't say with certainty that a mission that I choose will require me to do this, I'm just going to pick a random IP address and find a computer that has no open ports on that network. So let's go. So I think if I do that, there we go. Got a random IP here. And let's probe it and see what we get. Okay, there are some ports forwarded. Looks like we got ports going to 172.168.21.14 and 10.0.0 or 10.0.22.2. So let's find a computer that's got nothing forwarded to it. Looks like 192.168.1.2 maybe has nothing forwarded to it, and I don't see it in the list at all. We have, so up here are computers that we know are on the network. This is all the devices we can see from outside the network. On this bottom part of the list, this is stuff that has a service running. So what I'm doing is I'm trying to find something in this list that's not in this list. And it looks like we just have the one here, which is 192.168.1.0. Now, since we're going to be looking for a bounce, since I've deliberately picked a target that has no ports forwarded to it, we have to make sure not to try to run any exploit on one of these ports. Because while running an exploit on these ports may get us a shell or a computer back, it will be for this computer. And we need something on the router. So we only want to run an exploit on port 0 because port 0 is the only way that we can access a router externally. So In shell, port 0 is the target by default. The IP address was set by running probe, so we don't need to use target. So I'm just going to go right into db-r, and that's going to run an exploit. So we got a lot of, oh, okay, we already have, okay, so I mean, this is a really easy example. You'll notice in this list we've got a guest file, we've got 2 guest shells, we've got a guest computer. So this is already what we want. Like a computer on a router, that's a bounce. So we can use this exploit to immediately get us access to that target. But I'm going to go do it a little bit more difficult. So if we wanted to, what I would do to do this is I would run zap. You know, to run the exploit that will get us the bounce, I would run zap. I would choose 1 from this list here to run this particular exploit. And then zap is going to ask me for an IP address or a password for the inject value. And what that means is in the actual code, when you run the overflow method on that metalib object, you would normally pass in 2 values, which is the address, the memory address, and the unsafe string. But it takes, you can also optionally pass in a 3rd argument. And what that 3rd argument, or what that 3rd parameter does and what it is different depending on what kind of vulnerability you're exploiting. So it's used in 2 different cases. So it's used for password resets. So if you're going to run an exploit that resets a password, the value you would pass in as that 3rd parameter is what you want the new password to be. Or if you use it in a bounce exploit, the value you would enter for that 3rd parameter would be the LAN IP address of the computer that you want to get the returned object for. So in this case, we want to bounce. I'm going to put in the IP address from that list, which was 1.2 or 192.168.1.2. Sorry, not 12.2, and that will get us a computer. Now we know it's going to be a guest computer because we saw that from the list, and that's what we've got here is a guest computer representing that target on the network. So I mean, it was really that easy. I'm going to back out now. So this gives us a computer object. We're not all the way to a shell yet, but I'm going to back out from this and show you, like, if it wasn't that easy, if we didn't immediately have a bounce from, you know, the port 0, what we would do instead. So I'll quit out of this. I'm going to purge the buffer. And we'll essentially start over. So I'm going to run probe show, which gives us our cached probe results. Let's run zap again. And this time I'm going to do one of the shell exploits. So let's assume we don't have a computer bounce vulnerability like immediately, like we did this time. But say we only got a guest shell or something. So let's run one of those. We'll do, I guess, 4. Leave it blank because we're not passing in the 3rd parameter. Open the shell in the buffer. Yes. We're going to upload the rkit with 3. That's uploading. Would we like to run shell silently? Yes, with no parameters. And now we're on the router in the network. So once you're on the router, you can actually exploit the local libraries. So kernelrouter.so is on there, which we were able to exploit by doing port 0 remotely. But the other libraries you can't exploit from outside of the network. There is libhttp is on the router as well. All routers have that. And you can exploit that from a different computer inside the network, but you can't do it from outside the network. And then there's also some libraries that can only be exploited from the actual router itself. So net.so is one. There's also init.so. Both of those are really good for getting bounces. So to see what options we have, if I do ls/lib, since that's where the libraries are, okay, so that's the 4 options. We have init.so, kernel.so, or kernelrouter.so, net.so, and libhttp.so. Okay, so let's start with net.so. In order to scan this using fast hardware, which is not a router, routers have very slow hardware, I'm going to use the meta exploit library on my own computer, which I've covered in a couple of different videos, and I'll explain it briefly as we go along here. So, but the first thing I want to do is set the target. So I'll do meta load to tell it which which library, and let's do net.so. So we got net.so version 1.0.5. That one might be a little tricky. That one might not have what we need, but let's try it. And then to switch to using my own meta exploit library on my own home computer, or my rental in this case, I'll do meta import at O. At O is the shortcut to referencing a cob object, and then myx0. And just to show how I know to do that, so anytime you get shell on a computer and run it, it's going to add the meta exploit library from that computer to the custom object map. And the meta exploit, the key for the meta exploit libraries is myx followed by a number. So myx0 is always your origin. It's the home computer, or in this case, my rental computer. And then every one subsequent will be myx1, myx2, etc. And you can look at those. If you do cob indexes, you can see those. So this myx0 is my home meta exploit library. And this myx1 is the one that's on the router. And the router wouldn't have one normally. It's only there because it's included as part of the RKit that we uploaded. So, okay, so we've linked, or we've loaded net.so with meta. We've imported my home meta exploit library. Now I'm going to do the scan. So meta scan. You can see it goes very fast. So we have a lot of exploits here. So I'll hit return. Meta restore will swap back to the meta exploit on the router, and then roil will run those exploits. And so what we want here is we want one that says something about an IP address needed. That'll be a bounce. So if we look through these errors, we've got no guest user, unable to find non-root user, unable to find non-root user, no active root user, no active root user. Here we go. No LAN IP indicated or invalid. So this one is the one we want. That's going to be our bounce exploit. And I think net.so 105, this might be a root computer, which if so, that's pretty sweet. But let's find out. So, okay, so what do we have here? So we have this address and then the string formalcon. So we want to run that specific exploit. So let's do zap and formalcon. So that's going to be number 6 in this list. So we'll type in number 6. And it's going to ask me for a password. So again, or not a password, I'm sorry, the LAN IP or password. So again, I'm going to type in 192.168.1.2 since that's the target I picked. And now we have our computer. And it's a user computer this time, not a guest computer. So that's slightly better than what we got from port 0 running externally. So, so from here, what I'm going to do is I'm going to collect the home. You type 1 here to collect the home contents. That's going to be mail.txt, bank.txt for all users on the computer, which there is at least one, we know, because we have a user. So it's frills is one of the users. Hopefully there will be 2, so we can do a funny game without having to, try another target. But let's just see what we get. So press 1. So it's going to go through the contents. We do have a second user. The second user's name is Dude. That's the username, which is pretty interesting. And then I'm just going to do a real quick, what am I trying to say? Decipher on these. Just in place. Normally I would transmit to hashem, but I've shown that a bunch of times, so I'm trying to do some different stuff. So let's do, I think it's still hashem, maybe? Or gopher at tbuff. There we go. Gopher at tbuff. And it deciphers all this stuff right in line. So we've got an email address here. And that's going to be, or no, that's a bank. That one's a bank account. Let's see. This one, I think, is an email address. So the blue ones are email addresses, the green ones are bank accounts. So that's kind of nice. So we've got an email address here, so let's grab that. We'll copy, and then we'll open up our mail account. This is, now we're onto the rshell process. So once you have your computer object for the target computer, you would use it to read the mail.txt files so that you can get mail credentials, so that you can then send an email, the funny game social engineering email, from one user in the network. It doesn't have to be a user on that computer. It just has to be one with the same domain name or company or whatever, to a user on that computer. Because you want a user on that computer to run this funny game program to give you your rshell. So, so what I'm doing is I've opened mail.exe. I'm going to log in with the email address from that from that mail.txt file. We've got the password, I believe is this one. So we'll paste that in there. Okay. So I've logged into the email address, or to the email right there. I'm going to compose a new email. We'll go scroll down here and we'll choose the funny game email. And I'm going to send it to the other email address on that computer, which is this dude account, dude at whatever. So we'll copy, paste. I don't need this guy's password, but I do need the IP address for the server. So if config public IP is here, so we'll copy that and paste it in. I run a non-standard port, which I've mentioned in previous videos, and we'll send. So we get a response back. I just ran it, hope it's gory, which is what we want. I'm going to delete the email even though it doesn't matter. And we're done. So now you can corrupt logs and stuff from a computer object. So like we can corrupt the logs with this computer object right here with sclean. But we have a shell now, so we can just do that. So so if I run I'm going to clear this real quick. If I run RSI, oh, am I not? I'm on the router. That's right. I'm still on the router. So let's clean up the. I'm guest on the router too. All right. So I want to clean up this router real quick before I leave. So let's go back to that computer object. And this time I'm going to grab the password file, and we'll go for that. And I'm looking for a root password because I want to escalate to root so that I can clean up, I can run silentclean and whatnot on the computer. So it looks like, let's see, do we have root? Root password is Torma, looks like. So we'll do sudo -s Torma. That'll give us our root shell. View context menu and buffer, I'm going to hit yes. So I'm now looking at the context for that root shell, and what I'm going to do is I'm going to just rclean. So so we'll rclean that, and then I believe I can just you know what? Actually, let me add that to Cobb so I can do it remotely. I don't know. I prefer to do it remotely. So that way it can be like the last thing I do before I leave. So we'll send it to Cobb with shell as the name. Quit Y. So now I'm back on my home computer or my rental computer. I will purge the buffer since I'm replacing the shell that's already in there with the root shell. Cobb get shell malp. So now, okay, so there's that root shell and malp, and I'm gonna just rclean it. It would be wise, you know, to go in and use that shell to delete the rkit folder as well. But I don't want to, you know, go and run it and do all that. So what I'll do is I'll open Glasspool, because I think you can do silentclean from Glasspool. So we'll do sc-d from Glasspool. And then if I do tree, I believe that will show me, yeah, no rootkit folder anymore. So we've cleaned up after ourselves. When you're in Glasspool, I think you can do return to drop out of Glasspool. And okay, so now we're back to the buffer. I'll leave it there for now, but what I need to do is gain access to that computer we picked as the target, which is again 192.168.1.2. So we'll hit RSI, and here is our shell 192.168.1.2. So we'll hit 1 to access the shell. Let's add it to the buffer so we can access it from there. We'll go to malp 5 for the buffer. Here is our shell running under the username dude. So we'll access it with 2. We'll upload the rootkit with 3. Run shell, no parameters, psudo-s, I believe it was torma, and we'll view the context in the buffer, add to cob, shell, and quit. Quit y. So now I'm back on my rental. Quit out of this, purge the buffer again. Yes, and then cob get shell retrieves that root shell from get custom object, and we'll pipe it into malp to add it back to the buffer. Except that didn't look like it worked. Cob get shell space malp. There we go. I think I put an extra space on it, and that must have messed it up somehow. So, okay, now we have a root shell on the target computer. That computer had no open ports, but now we have access to it. So I'm going to real quick do that same thing. I'll do glasspool sc-d to clean up like I was never there. Return, purge the buffer. Yes, and then we'll clean it up in RSI as well. So select 1. We'll kill that port 6178, and now it's cleaned up from RSI as well. So we've left no trace, and we're all the way backed out of it. And that's how you do it. Gain access to a computer with no open ports with shell. Thanks for watching, and hope to see you next time. Bye.